There's something out there in our universe that astronomers cannot explain, and it might just break the laws of physics. In today's video, we're going to explore what that is, how it defies our scientific understanding, and why some are calling it the monster that shouldn't exist. So buckle up, because this is one wild ride through the cosmos. Now, before we delve into the details of this mysterious phenomenon, let me ask you a question. Have you ever looked up at the night sky and wondered about the vastness of our universe? Do you ever feel a sense of awe and wonder when you contemplate the mysteries of space? If so, I have something special for you. Okay, now back to the show. Located approximately 12 million light-years away from Earth in the M82 galaxy, astronomers have discovered an X-ray star that challenges our understanding of physics. It's not just any ordinary star. No, this one shines with a mind-boggling brilliance, emitting energy that is 10 million times greater than our Sun. That's a truly astronomical amount of light. Such celestial objects are known as ultraluminous X-ray sources, or ULXs, which astronomers have been discovering since the late 1970s. These enigmatic stars possess masses ranging from several to hundreds of times the mass of our Sun. However, they emit an astonishing amount of energy, making them among the brightest objects in the universe. The only things that outshine ULXs are gamma-ray bursts, supernova and quasars, but here's where things get really interesting. Despite their incredible brightness, ULXs don't quite fit into our current understanding of physics. You see, there's a physical principle known as the Eddington limit, which basically sets a threshold for how bright an object can shine without exploding. According to this principle, the brightness of an object is restricted by its size. To be more precise, scientists estimate that the maximum brightness of an object is around 150 times the mass of the Sun. Anything more and it should well blow itself to smithereens. And while you might think that sounds pretty straightforward, it's actually a bit more complicated than that. You see, the reason why this principle exists is because of a balance between two forces. One is the gravitational force, which pulls everything towards each other, and the other is the radiation force, which pushes stuff away from each other. Basically, it's like a cosmic game of tug-of-war. Gravitational force wants everything to be as close as possible, while the radiation force wants everything to be as far apart as possible. When it comes to things like stars, the gravitational force is usually stronger because it pulls all the matter inwards towards the center of the star. This creates a massive amount of pressure and heat, which generates light and energy. However, when an object gets really massive, like hundreds of times the mass of the Sun, the radiation force starts to become more significant. As the object gets brighter, the radiation force pushes outwards, trying to balance the gravitational force pulling inwards. If the object continues to grow in mass, eventually the radiation force becomes stronger than the gravitational force. At this point, the balance is broken and the object can no longer hold itself together. Instead, it explodes and scatters its material into space. And here's where things get really weird. While the Eddington limit has been observed for smaller objects like white dwarfs and neutron stars, it seems to be thrown out the window when it comes to ULXs. You see, these objects are incredibly massive, but they also seem to be incredibly small, possibly no bigger than a few dozen kilometers across. If that's the case, then according to the Eddington limit, they should explode, but they don't. Instead, they emit an astonishing amount of energy, up to 10 million times that of our Sun. To put that into perspective, if our Sun were an LXC, it would be as bright as 315 trillion stars combined. Now, astronomers are still scratching their heads over this one. They've come up with some theories, but none of them seem to fit all the pieces of the puzzle. One possibility is that LXCs are actually even smaller than we think, maybe only a few kilometers across. If that's true, then they'd be emitting an insane amount of energy per square kilometer, which could explain why they don't explode. However, there's no evidence to support this idea, and it would also mean that LXCs are incredibly dense, perhaps even denser than neutron stars. Another possibility is that LXCs are made of exotic matter that we don't know much about. This type of matter would have to have a very specific set of properties, and it would also require some new physics to make sense. But, hey, stranger things have happened in the world of astrophysics. One of the leading theories at the moment is that LXCs are neutron stars with extremely strong magnetic fields. This could explain why they emit so much energy without exploding, but it also raises more questions than it answers. For example, how do neutron stars get such strong magnetic fields? And what happens to the material around an LXC? Well, here's where things get really messy, literally. You see, the intense radiation coming from ULXs doesn't just blast out into space. It also creates a shockwave that blasts outwards at tremendous speeds. This shockwave can travel hundreds of thousands of kilometers per hour, and it plows into the gas and dust around the ULX, creating a bubble-like region of space that's completely blown apart. This process is known as galactic wind, and it is thought to be one of the reasons why galaxies like M82 have such enormous black holes at their centers. You see, as the galactic wind blows outwards, it carries with it a lot of mass and momentum. This can eventually build up enough pressure to push against the gravity of the central black hole, causing it to start growing faster. So not only are ULXs challenging our understanding of physics, but they're also shaping the evolution of galaxies in ways that we're only just beginning to understand. And while astronomers continue to work on unraveling the mysteries of ULXs, one thing is clear: the more we learn about the universe, the more bizarre and fascinating it becomes. Who knows what other wonders and mysteries await us in the vast expanse of space? All we can do is keep looking up and keep asking questions. Meanwhile, if you want to keep learning about the amazing discoveries being made in the world of astronomy and astrophysics, I've got some great news for you. Check out our other videos where you'll find all sorts of fascinating topics covered. We've got videos on black holes, on the James Webb Space Telescope, on exoplanets, and on all sorts of other cool stuff. Plus, we're always coming out with new videos every week. In fact, I've got a video in the works right now about the recent discovery of a planet that could have life on it. So if you want to be the first to know when that video comes out, make sure to subscribe to the channel. It's totally free and you can always change your mind later. But seriously, you don't want to miss this one. And if you do end up liking our videos, please consider supporting us. It helps us make even more great content and allows us to continue sharing our passion for space exploration with all of you. Thanks so much for watching. Alright, now let's get back to the show. Another strange aspect of ULXs is the way they interact with their surroundings. Unlike most stars, which are surrounded by a relatively empty bubble of space, ULXs are often found in crowded areas of galaxies where there's a lot of gas and dust floating around. And they don't seem to mind at all. You see, most stars emit radiation that travels outwards in all directions. But the radiation coming from ULXs is so powerful that it actually pushes the surrounding material away, creating a bubble of space that's completely devoid of gas and dust. This is known as an H-alpha bubble, because it's full of hydrogen gas that's been pushed out by the intense radiation. And these bubbles aren't just interesting to astronomers, they're actually super helpful because they allow scientists to study the material that's inside them. You see, the material that's blown out of an LXC isn't just regular old gas and dust. It's also full of heavy elements like iron, nickel, and zinc. These elements are created when massive stars collapse and explode as supernova, and they're some of the building blocks of planets and other solid objects. By studying the composition of the material in H-alpha bubbles, astronomers can learn more about the chemical activity happening around ULXs, and they've made some surprising discoveries. For example, they've found that some ULXs emit huge amounts of neon and oxygen, which suggests that they're powered by a gigantic engine that's converting mass into energy at an incredible rate. And while all this research is still in its early stages, it's already shedding new light on the bizarre world of ULXs. One thing is clear: these objects are not just massive and bright, they're also incredibly complex and fascinating. And as astronomers continue to study them, they're sure to make even more surprising discoveries. So the next time you look up at the night sky, remember that there are all sorts of strange and wonderful things happening out there. We may not be able to see them with the naked eye, but thanks to modern technology and the hard work of astronomers around the world, we're learning more about the universe than ever before. And who knows what other mysteries we'll solve in the years to come. Until then, keep looking up.